The question we're having today says the radius of the Earth is 4 times the radius of the Moon, and the acceleration due to gravity on the Earth is 80 times that on the Moon. We ask, what is the ratio of the mass of the Moon to that of the Earth? If you watch this, they mention two things. They mention the Earth, a planet, and they mention the what? The Moon. Is that clear? That's what I've been seeing here. Now they told us something that the radius of the Earth, let's call the radius of the Earth R subscript E, is 4 times the radius of the Moon. So it is equals 4 times the radius of the Moon. Let's take the radius of the Moon, 4 rm. So this is what they say. This is their first statement. And the acceleration due to gravity on the Earth, let's take the acceleration due to gravity on the Earth as G subscript E, is 80 times that on the Moon, is equals 80 times the acceleration due to gravity on the Moon. Do you understand? Now they asked us, what is the ratio of the mass of the Moon to that of the Earth? They're asking us, what is the ratio of mass of the Moon, let's call it M subscript M, to the mass of the Earth? This is what they're asking us. Now, for us to solve this question, we should remember the formula, or let's say the equation that relates the acceleration due to gravity and the universal gravitational constant. Now, in one of my videos, this video that the caption says why the Earth, why the acceleration due to gravity is not constant, why it is greater at the poles. I derived something there which says that the acceleration due to gravity on a particular place or on a particular planet is equals the universal gravitational constant times the mass of that planet or the mass of that particular place all over the radius of that planet. Do you understand? The square of the radius, I mean. We derive something like this. If you've not watched that video, why this acceleration due to gravity is greater at the poles than at the equator, please, I really advise you to go and watch it. Now, having this formula, if we want to write this kind of formula based on the Earth, we said that the acceleration due to gravity on the Earth is equals the universal gravitational constant times the mass of the what? Earth all over the square of the radius of the Earth. Hope is clear. Now, if we want to write this formula again based on the Moon, we have that acceleration due to gravity on the Moon is equals the universal gravitational constant times the mass of the what? Moon all over what? The square of the radius of the Moon. Hope is clear. It should be. Now, they gave us that the radius of the Earth is 4 times the radius of the Moon, and the acceleration due to gravity on the Earth is 80 times that on the what? Moon. So wherever I will see RE, we'll put this. Wherever I will see GE, we'll put this, right? So GE now, I'll be having 80 G subscript M is equals the universal gravitational constant times the mass of the what? Earth, which is M subscript E, all over what? The square of the radius of the Earth, which is what? 4R subscript M. Don't forget to put the word squared. Hope is clear. So this now can mean 80 G subscript M is equals the universal gravitational constant times mass of the Earth all over multiplication law. 4 squared is 16 times the radius of the Moon squared. So I will take this as my equation 2, and I'll take this one as my equation 1. Do you understand? So I'm having equation 1, I'm having equation 2. For this one, there's nothing I can do here. The only thing I can do for now is just to do mere relation. So when I can say equation 1 divided by equation 2. So when I say this acceleration due to gravity on the Moon divided by acceleration due to gravity on the Earth, which is this whole thing. Remember this. So this divided by this all over 80 G subscript M will give me what this divided by this will give. So I have G M subscript M all over what? R M all squared. Then divided by this, right? G M subscript E all over 16 R M squared. Hope is clear. So I'm having GM will cancel GM, right? So what I'm equally having here is when it comes to, I'm having 1 over 80 is equals GM subscript M all over RM squared. Then times you invert 16 RM squared all over GM subscript E. So GM subscript E, right? So this can cancel this, right? the universal gravitational constant cancels. So what I'm having left is 1 over 80 is equals this times the 16 times mass of the moon, that's 16 mass of the moon, all over, then ME is remaining down. You understand? Now let's ask ourselves, what did these people even ask us to find? They asked us to find mass of the moon over mass of the earth. And I'm seeing mass of the moon over mass of the earth. So it means that when I try to cross multiply, just only this 16 should go down. I'll be having that 1 over, watch, I'll be having that 1 over what? 80 is equals 1 over 80 times 16 is equals mass of the moon all over mass of the earth. Is that correct? Now, 1 over 80 times 16 is 1280. So this is 1 over 1280 is equals mass of the moon over mass of the earth. So the answer is actually, they say, what is the ratio of the mass of the moon to the mass of the earth? Now, mass of the moon to mass of the earth is this 1 over 1280, or you can say 1 is to what? 1280. This is actually what? Correct. I hope you understand. Have a nice day. Like, comment, share, and follow Courses Academy. Bye bye.